desktop because I can just, hit the button and then scroll with the scroll wheel or whatever. But my laptop is a huge hassle.
And I'll probably want to, so I was assuming you wanted to share the deck with people, but I'll probably want to share directly from my screen for
There you go. Okay.
Stream.
Testing, testing.
I was gonna say, like, I can pull the stream back up again, but
Yeah.
I definitely heard you through before.
Okay.
You guys good?
Good, I think so. Can you guys hear me?
Yeah, it's just, the stream's on, but it's
The
good.
stream's on, but can they hear you on Discord?
Can anyone on Discord hear me?
BitHaven looks muted. Does BitHaven have to be unmuted?
Yep. Might be part of the. Good catch.
Test again.
Testing. Can you hear me on Discord?
Yes, we can.
Fantastic. We're juggling all the pieces with Discord and Twitch and everything
OBS
else and OBS and trying to get all this working.
And Steven at the time crunch.
Do you have a meeting?
He's got a appointment
work?
at 6.
All right, just going to mute again. I'll be back in a sec. Hello, everybody. How you doing tonight? Be interesting to see how many people we get showing up. I think we had like 35 RSVPs, but I don't know how many are in person and how many are going to be on Discord. So, and how many were just bots. So I guess we'll find out.
My wife is supposed to join.
I'm sorry, what was that?
How's your night going so far?
Going well. How about you, Mark? Where are you at this week? Nope, not coming off mute. Must not have heard me. How many people are attending this meetup for the first time?
Hey.
Excellent. Welcome.
Yep. Hello.
Including me,
Thanks
got
to
like
it.
7 people on Twitch.
Nice.
Just have to say Meshtastic.
Popular topic. So, for those of you I haven't met yet, let me turn my camera on here so you can see me. For those of you I haven't met, my name is Matt. I've been organizing this meetup since 2019. We generally do a monthly meetup every month except for December because we all have enough stuff going on in December. We usually do 2 or 3 months like this with technical speakers talking about a particular topic. And then we'll do a social event like a happy hour or a picnic or a party, something like that. So we're trying something new the last couple of meetups. This originally started as an in-person event. And then, as you all remember, COVID happened and there were no more in-person events, which is when we moved it onto Discord. And then last year, our friends opened the Bithaven Hackerspace. So we've been doing these as hybrid events where we stream them on Discord and on Twitch. But we also have them in person here at Bithaven. So if you would like to join us for a future event, Bithaven is in the Tri-Main building, the old Ford plant on Main Street. It's a very cool space. You should come check it out if you haven't already. And hopefully we'll continue to do that. Nice thing about doing it on Twitch as well as on Discord is that we're able to stream it to a larger audience and also record it and put it up on the Bithaven YouTube channel later. So if there's something that comes up tonight that you want to go back and revisit and rewind, that's a good opportunity to do that. Our general format is I will start off. I've got a short slide deck. You can probably see it in the streaming box there. It says Infosec 716. We talk about sort of security news the last couple of months, upcoming events that people might be interested in, and then I will turn it over to our featured speaker. So let me just switch to my other desktop here so I can get to my slides. There we go. All right, so Infosec 716 meetup, January 21, 2026. First of all, I just want to say welcome to year 8. I got this email from Meetup the other day. Happy anniversary. So we have now been doing this for 7 years, 70 some different events, which has been really cool. When this started off, it was like 2 or 3 people in a spare classroom at Kenesha, so it's been really neat to see how it's grown over the years, and I'm glad you all could be part of it. As always, we start off with our security dumpster fire of the month. This month, there were a lot of great candidates, I'm not going to lie, and it is an honor just to be nominated, but I have to give the nod to our friends at Grok. Dear Lord. Everything has gone wrong. Well, not everything. Somehow, the world's richest man is running a CSAM generator is not the leading news story on every channel in the world, but they have definitely had some serious issues. There was also a report that a couple of the Doge folks from last year, you remember that whole project, were sharing Social Security data with a quote-unquote election integrity group. And so they're being brought up on Hatch Act charges, which is really exciting. So I guess we'll see how all that goes. So welcome to the dumpster fire, Elon and Grok. Some other headlines. ICE is using a mobile app they call, is it Mobile Fortify? Is that the name of it? Does anyone remember? That allegedly does definitive facial recognition that is more reliable than a passport, a birth certificate, or a driver's license, and it keeps misidentifying people. So that seems bad. A couple stories about Flock. For those who haven't seen it, Flock is a third-party company that runs automated license plate readers. It also has some integrations with Ring and some other sort of surveillance technology. Flock made a couple of mistakes recently. One, it exposed a bunch of cameras to the internet without people realizing it. So the folks at 404 Media discovered this. They were able to just log in and watch the video streams, which seems bad. And also, because Flock is... Danger. I'm sorry, I didn't hear that. Okay. Also, because Flock is a third-party private service, the requests that go to Flock are logged and can be revealed using Freedom of Information Act requests. If you file a FOIA with your local police department, you will see what they've been asking Flock for. And a lot of times what happens is these requests are filed and they'll say, show me any Flock requests for this particular license plate. And the police department will instead respond with all of the requests that were issued from their department or in their region in one giant spreadsheet. So if you're familiar with the site Have I Been Pwned, that tracks data breaches and where your credentials might have been compromised, there is now a comparable site called Have I Been Flocked, where you can go in and search for a license plate number and see whether it has been requested, where it was requested, and what the results were. There's also a field where the person doing the search, I don't want to say officer because sometimes it's an officer, sometimes it's an administrator, but the person doing the search has to justify why they are searching for that license plate number. So you can go in there and see not only whether you're being searched for, but why you're being searched for, which is an exciting new violation of privacy. All right, moving on. A man was charged for wiping his phone before it could be searched by Customs and Border Patrol. They have not actually explained why they wanted his phone. They have not explained what they thought was on it. But they have tried to charge him with destruction of evidence because he wiped his phone before they were able to seize it, which seems, I don't know, I'm not a lawyer, but seems bad. A unsourced report says that a cyber attack was part of the U.S. assault on Venezuela. I don't know how much stock to put in that because a lot of the implication, I guess you'd say, a lot of the inference is that there was a cyber attack that was related to taking out their power grid. But on the other hand, we also dropped big bombs on a bunch of electrical subsystems. So it seems like that was probably the more effective of the two attacks, but I'm no military strategist. I just thought it was interesting because, the whole argument over whether cyber is a legitimate domain of war and how it's going to fit into these sort of operations and so on has been really interesting to watch. And so there's been some, not so much reporting, but some really interesting interpretation of this event. There was a cool write-up in Bruce Schneier's newsletter, I can't remember if it was this month or last month, about hacking wheelchairs over Bluetooth. There was a particular vendor who had instituted like a Bluetooth control for their powered wheelchairs, but did not put any kind of controls on pairing. So if you're near one of them, you can just point your phone at it and start driving them around like a Power Wheels. Seems bad. Just one more example of why vendors need to think about security while they're designing these interfaces and these products rather than trying to slap it on after the fact. And in completely predictable nerd news, the Cryptographic Review Board had to nullify their election because they lost the decryption key to decrypt the results of all the votes. They came up with this elaborate system where all of the votes in the election were verifiable and were encrypted, and the decryption key was split across 3 people, and then one of them lost their piece. So they had to go back to Jump Street and do the whole thing again. This time re-engineered with it. You know what? If we have 2 out of the 3 keys, that's all we really need. That's the only requirement. So let's re-engineer this. Years ago, I listened to Mark Manning give a talk, I think it was at B-Sides Rochester, about sort of all the problems with GPG and how you couldn't do things like revoke keys, right, that were out in the field. It just reminded me of that. Like we come up with these encryption platforms, these encryption scenarios, and then they fail upon first contact with real usage. Bad news for anybody who bought a smart toilet. The camera in Kohler's smart toilet is not, in fact, your end-to-end encrypted. So, keep that in mind. Some sort of poo in the middle attack. Is Rowan on? I think he posted the link to this one in the Discord, but there was a Bluetooth hijacking attack that came out the other day. Does anyone know about this one? No? Okay, not hearing anything. But it's in the security news channel if you want to read up on it. I didn't have a chance. I just grabbed the headline for the slides. And finally, we all had a good laugh at this. The New York City mayoral inauguration banned Flipper Zeros and Raspberry Pis. Why those particular platforms were banned and not like those cool pagers all you kids have, I don't know. But I thought that was an interesting little piece of security theater. All right, that's all I got for security news headlines. Does anyone have any stories I missed? Anything they want to talk about? All right, hearing none, I will move on. So, some upcoming events that might interest people at this meetup. Infotech Western New York has posted that they're offering tours of Colo Crossing for the next couple of days. Colo Crossing is, Taylor, you've been there, right? That's the big data center down in the Main Place Tower.
Yeah, just know if you actively start unplugging things, you are combating fraud.
Okay, so they're a gray area, operationally speaking. But if you've ever wanted a chance to see like a legit colo, that's a pretty cool opportunity. InfotechWesternNewYork.com, I think, or .org is their website. You can go there and sign up for a tour. I don't think there's any charge, even if you're not a member. The folks at Black Hills Information Security are doing a couple of pay what you can events for people who are, especially people who are new to the field or people who want to train up in a new area. What Black Hills does is they offer their full, corporate top of the line training, and the deal is you pay what you can. I think the minimum is $25 for most of their courses. And this is stuff that normally sells for hundreds of bucks, but they're very dedicated to the idea of getting new people into the industry. So on the 30th, Troy, who has actually spoken to this meetup before, is doing a one-day class on foundations of network forensics that looks honestly really good. I might sign up for that one just to see what he's teaching so I can use it in my own courses. And John Strand, who's the founder of BHIS, He's doing his Getting Started in Security course at the end of February, and that's always a great one. That's like a 4 or 5 day course, access to a lab, all kinds of cool stuff. Rochester 2600, as always, first Friday of the month, so that'll be February 6th. Our next meetup is going to be on February 18th. I need to update the meetup site, but I think we've got someone coming to talk about Graphene OS, the secure cell phone OS, so that'll be neat. And then in the coming months, SANS has a couple of summits. They've got their OSINT summit and their Cybersecurity Leadership Summit coming up in March. If you have SANS certifications, I know I say this every time, I apologize for being repetitive, but the SANS summits are free. They are absolutely amazing training. And if you have SANS certs, they automatically apply the CPEs to your renewals. So if you have certs that you need points for, that is a great chance to get them for free, especially since SANS is so, what's the word I want to use? Diligent about accepting CPEs from other sources. This is a good chance. And then starting in March, our regional B-Sides get going. B-Sides Rochester is going to be on March 21st. B-Sides Buffalo will be on June 6th, and then B-Sides Pittsburgh will be on July 10th. The reason why I have stars for Buffalo and Pittsburgh is because the CFPs are open for those events. So they are actively seeking submissions, and I believe early bird tickets are on sale already for Pittsburgh. So it's a good chance to do that. I'm sorry? Okay. Any other events? Anything else coming up that people want to mention? All right. With that, I am done with my slides for tonight. Tonight's speaker is SnyderMesh. He's going to be talking about Meshtastic. So I will go ahead and turn off my stream so that he can turn on his. And I'm really looking forward to this. Seems like cool stuff.
Yeah, I feel like this, like, you know, signing up and bring up, like, the temperature, it's every hours.
I'm sorry, what was the question? Okay, slide the mic over for you here. You want to go ahead and stream?
Yeah, let me make sure I've got this right.
All right, so Taylor, you got to cut over to his.
Yeah, I'm trying to figure out how to do that.
Are you sharing your screen?
It's showing it, Sharon.
Okay. Yeah, well, no, I'm seeing your screen. I'm not seeing an application, so.
I couldn't find one of
There
those.
we go. Perfect.
All right. Well, thank you everybody for joining. I wanted to say thank you so much for inviting me to BitHaven to speak for this Infosec 716 event. This is really my first time reaching out to a non-ham radio audience about Meshtastic, so I think it's hopefully going to be fun and interesting, and I'll try not to get too deep into the weeds, but I'll provide some links and some additional information, so if anybody does have any kind of like deeper questions, we can dive right into it and go from there. Got a lot of content, so we'll move through pretty quickly, but feel free to interrupt me if you've got any questions. I'm happy to take questions kind of throughout. All right, so just what the heck is Meshtastic? It's an open network for building decentralized communications. It's a low power, low data, long range protocol. It's a mesh network that can reach vast distances with multiple hops. It can go really far. The current record is just over 200 miles. So that's Greece to Italy we're seeing there. And so Meshtastic is worldwide. There's many different meshes in the United States, and there's many users in Western New York and growing. What we're looking at here is a map of people that are connecting their nodes to the internet, and they're sharing their position. This is about a third of the Meshtastic users in the area that we're seeing here. Hi, welcome.
I'll leave my stuff right here.
So one of the key things about Meshtastic is that it works when most other solutions won't. It works during natural disasters, grid outages, and in backcountry communications situations. And it works in noisy environments where there's a lot of RF noise that would be typically blocking other signals operating at that kind of like level of the spectrum. As you can see here, it can actually operate about 20 decibels below the noise floor, and it behaves as if it's 10 decibels above the noise floor. And we'll talk a little bit about why that's possible. It is encrypted. The older versions of the firmware use a per-channel pre-shared key, but the newer firmware now has full AES 256 PKI per node encryption, and that's going to make direct messages more secure. It can be tactical, so you can understand positions of nodes and bring together the different information exchange between you and members in the field from more of like a command center kind of point of view when you're connecting through these different nodes. And so here's some examples of kind of what that looks like. So I guess the biggest thing is, are you excited yet? Well, we really didn't talk about what it does. It's offline texting. That's pretty much what it does. Meshtastic can send text and very small data packets like GPS coordinates and sensor data. It's relatively cheap, completely open, and the LoRa protocol is pretty amazing. It has one job, but it does it really well. But you might be asking, so it can send text messages and data chunks. What's the big deal? We've got cell phones, we've got Wi-Fi, we've got tools that can meet this need. Well, LoRa, the underlying technology of Meshtastic, and Meshtastic do those text messages really well with no help from anything else. So you don't need cell phone towers, you don't need internet, you don't have any dependencies on other infrastructure. So if you've got no cell service, no Wi-Fi, no line of sight, no power grid, lots of noise to compete with, which is another no if you look at noise, then you've got no problem, right? So let's dive into the technicals a little bit more in depth. So it's an open source data network that rides on the existing LoRa Internet of Things protocol. It's a full mesh network up to 7 hops deep. 3 is pretty normal. In North America, it uses the license-free 900 megahertz ISM band, industrial, scientific, and medical band, and really operates between 902 and 928 megahertz. And there's 104 different frequency slots for that data, up to 30 decibels ERP at 1 watt. What does that mean? Your device can push up to 1 watt out of the antenna and try and reach your neighbors with that radio signal. Some examples of other radio technology that you might be thinking about, most handheld GMRS style walkie-talkies, those are going to be in about 5 watts. It does not support video communication, just the text-based messages. We'll talk a little bit about the bandwidth of data that can flow through. Typically, it's about 1 kilobit per second. So that's much slower than even your dial-up modem was back in the 90s. But it's good for this purpose. Licensed amateurs can push 10 decibels or 10 watts, I mean. So they can do more, but there's some important constraints that we'll call out. And there's different rules for amateurs with a license to do ham radio versus traditional civilian use. The default long fast mode for Meshtastic yields that 1 kilobyte per second of data, and the range, like we described, could be up to 200 miles. So what is that LoRa? It's a physical proprietary radio communication technique, and it's based on spread spectrum modulation techniques called chirp spread spectrum. LoRa is very commonly used as part of LoRaWAN, which is long range wide area network. And they kind of define that as a general communication protocol. It's an official standard. And so LoRa and LoRaWAN are used for low power wide area networks. All of your smart meters for your gas and electric in this area and all across the country, they're all talking to essentially through LoRa over the LoRaWAN protocol to different gateway devices that might be out at the street. And then that way they can collect your meter readings without having to send somebody around to physically inspect all of the meters. That's all happening with technology you've got at your homes already. Meshtastic uses a peer-to-peer version of LoRa as opposed to LoRaWAN, but it's pretty similar technology. So why LoRa? Well, LoRa is the magic that is behind Meshtastic and other systems like it. That chirp spread spectrum's the secret sauce that allows LoRa to maintain digital transmissions up to 20 decibels below the noise floor, far beyond most other solutions. This also makes it very difficult to block or jam. And so we can see an image on the left there showing a typical frequency shift keying digital signal over radio spectrum. Typically it would be operating by putting the ones and zeros by moving between two frequencies. So you'd be at one frequency and then move to the other frequency and then move back. And so you'd be able to denote, based on the timing of those signals, whether it's a 1 or a 0. Whereas chirp spread spectrum does it a little bit differently. It actually uses all of the frequencies between around that center frequency, and it'll draw symbols in the radio frequency. So it'll draw a symbol that's ascending or descending. And because of that, if you were to put a radio on any one frequency, you could block the frequency shift keying because it would be very hard to determine if we're operating in the high point or the low point. But if you were to put a signal on any one frequency of chirp spread spectrum, you'd still be able to make out that symbol, and that's what makes it kind of special. So now that we talked a little bit about the radio technology, well, what mesh? Let's talk about that. As you can see here, we've got lots of different devices that are all kind of talking to each other. And if we were to imagine a Meshtastic node on one side of the mountain and a Meshtastic node on the other side of the mountain, they wouldn't necessarily be able to talk to each other because Meshtastic is not a radio technology that goes through mountains. It doesn't bounce off of the atmosphere that well, that kind of thing. It's more of a line of sight. But when you have nodes in multiple places, those nodes can essentially pass messages between each other to get to the intended recipient. And so when you send a message on your Meshtastic companion app, it's relayed to the radio using Bluetooth or Wi-Fi or Ethernet or the serial connection over the USB cable. And then that message is broadcasted by the radio. If it hasn't received a confirmation from any other device after a certain timeout, it's going to retransmit that message 3 times. And then when a receiving radio does capture that packet, it's going to check to see if it's heard that message before. And if it has, it'll ignore the message. If it hasn't, it will rebroadcast the message. And so your node will then understand it's received an acknowledgement from that first device. It hasn't heard an acknowledgement from the intended recipient yet, but it's heard that another node out there has heard that message and is trying to push it further on. So for each message a radio rebroadcasts, it marks the hop limit down by 1. So when a radio receives a packet with a hop limit of 0, it won't rebroadcast it anymore. The radio will store a small amount of packets, about 30, in its memory for when it's not connected to a client app. If it's full, it'll replace the oldest packets with newly incoming text messages. See, yeah, and any questions, feel free to ask.
First in, first out.
Yeah, yeah.
So there's no endpoint addressing, just everything gets rebroadcast?
We've got some newer technology that helps with routing to get the message to a node that has successfully returned an acknowledgement in the past. If, for instance, you're direct messaging from A to Z, and you know it went through B and C, then it'll give little hints in the packet that'll say, first get me to A, and then it'll say, next get me to B, and then it'll get you to Z.
Kind of like the old email bang paths back in the day?
I
Okay.
imagine so, yeah.
How long does it retain the messages for, like, comparison?
Yeah, so it'll hold on until it's essentially pushed that, imagine 30 blocks, one pushes off as another one comes on. It could be more, it could be less, depending on the node itself. Different nodes have different hardware inside, and they try and exploit and take full advantage of that hardware.
So if it's on a busy day, it could be possible that it could receive the message and replay it again, just because it doesn't have that reference anymore, because so many have come in and already removed it.
Oh, so when we're talking about the actual sending of messages and them passing through the network, that's all going to happen inside of a matter of like a minute. It's going to be a short-term thing, and if it doesn't happen, if you don't get anybody to respond to that message, then you're going to get a message on your node that says max number of retries attempted. And so then you'll know your message never made it out to anybody. But let's say you leave your node behind, it's sitting at your desk at home, and you go outside, your phone's not with it, there's the node there to receive those messages. Well, it'll collect some messages for a while, and when you come back and you connect to it, you'll get those downloaded right to your app and be able to read those messages that arrived like an answering machine.
Gotcha, cool.
Now, with regards to the frequency usage, I mentioned there's 104 frequency slots in that 900 megahertz band. And so after your factory reset of the radio, it'll be set to the frequency slot number 20 in North America, with a center frequency of 906.875. So if you've got like a RTL SDR and you want to see what those symbols look like in RF space, you know where to look. Look at that 906.875. For the frequency usage, there's various data rate options that are available when configuring a frequency slot and are inversely proportional to the theoretical range of the device. So there's something called spreading factor. How much do we spread the symbol we're drawing in RF space over time? Each step up in spreading factor doubles the airtime to transmit. And so each step up in the spreading factor adds about 2.5 decibels of extra link budget. So imagine, if you will, I'm trying to send a message and I'm doing it over time, and I'm trying to move from this point in RF space to that point in RF space. If I have very little time, I can send a lot of messages. So I'll draw slashes like this. But if I have, if I spend a lot of time, then the slash in RF space, I only get one slash across. But imagine that now radio signal moving through space and time. If I draw something very slow and long, it's easy for me to see that symbol no matter how much noise there is. Whereas if I do lots, if I have a bunch of noise, I might miss some of those symbols, and so I might, screw up some of those bits in my reception. And then that leads to bandwidth, right? So how big of a slice of the spectrum we're using tells us how much bandwidth we've got. And so if we double the bandwidth, we're going to lose our link budget. And so we get this curve. And so our link budget versus our data rate, Meshtastic has these different modes, and we can choose the mode we want to operate on. Very long, slow, that's going to have an effective decibel gain of about 162 decibels a gain. That's very, very high. If we look at long fast, it's more like 153 decibels of gain. Every 3 decibels a gain is about a doubling in terms of how far that signal is going to go. Now, we see, though, very long slow has almost no bandwidth. It's going to take a long time for those messages to get across. Long fast has about 1 kilobit of bandwidth per second. And then there's even modes like short turbo, where maybe you don't need very long distance. They used, for instance, short turbo at Hamvention and at DEF CON, where they knew there's going to be a bunch of people all being densely populated with nodes. They want to make sure there's enough airtime for everybody's node to be able to talk on these networks. So they came out with custom firmware, but they used this mode on short turbo, and that essentially dramatically increased the number of nodes that could participate in the mesh at one time without stepping on each other. I think they had over 2,000 nodes all in a convention center, all connecting and exchanging messages with no challenges using short turbo. But for the best of both worlds, here in Buffalo, the one that we're all using and the one that's default on your device is long fast. So there's not anything you need to do. My goal is to get us to the point where we have to start thinking about moving a little bit down the curve. Maybe it's a medium slow or medium fast, so that we can accommodate more nodes in the area. Once we reach about 400, 500 nodes that are constantly meshed with each other in the area, we'll have kind of that need, but they're making other enhancements too that are giving us more bandwidth, so or less bandwidth consumed. So we might not need to make that move for a while. But areas like Austin, Texas, Austin Mesh, they've moved to medium fast, and they've been able to accommodate over 1,000 nodes at about 400s, where things starting getting dicey for long fast.
You did have a question in chat.
Yeah,
I don't know
please.
if you can see it. Are there any backdoors getting inserted into these devices with all the AI and frequency sensing? Are there ways to figure out what messages are being sent? The AI def is dang good at predicting based on all that infrastructure. So you might have to repeat the question because I don't hear it coming through because I'm so far away from it.
Okay. Yeah, so there is a question about AI coding being used to maybe interpret signals. And then there's also a question about backdoors maybe being placed into the Meshtastic firmware or applications, that kind of thing. I would say Meshtastic being that it's a open source software tool, you can go and inspect that firmware source code yourself and understand if it's meeting your security needs. I personally am not going to be sharing hypercritical information over it, but I still want to know that my messages between me and my neighbors and me and my wife are encrypted. And so as long as I'm not sharing my key from my channel with strangers, I should be in pretty good shape. I will say that Meshtastic is certainly prone to, anybody can record that spectrum and save it for later and put it on their hard drive. And when they've got quantum cryptography, they can understand all of those messages. So I think that's true for a lot of different technologies. But I'd say for the use cases, I feel pretty comfortable talking on Meshtastic, but I'd be careful what I'm sharing.
Man, in 2037, someone's going to know I'm out of detergent.
Yeah, yeah.
That and you can obfuscate the message. So like you can just have like words that you use instead of some words. So like if you are talking about your kids, you wouldn't say your kids, you'd say the hamsters.
Yeah.
Or something like that, you know?
That's what I call them.
We need another wheel.
Yes, we need another wheel.
Very good.
Question.
Please.
Came in at the very end of your beginning speech.
You didn't miss much here, guy.
Okay. What's the real world use case for this?
Yeah. it really started with backcountry hiking. And so people that were going out hiking up mountains where there's no cell phone signal, there's no Wi-Fi, there's nothing like that, they wanted to be able to keep an eye on their multiple groups. Maybe there's a group leader that's a little faster and a group leader that's a little slower. And so if everybody's carrying one of these tracker type Meshtastic nodes, this has a GPS device built into it, and it can ping and say, hey, I'm here, and share my GPS position to anybody that's on the same key as me. And then it also is, because of those types of uses, it becomes very valuable, because it works in those scenarios, it becomes very valuable for areas that are hit by natural disasters. So Asheville, North Carolina, when they lost their entire grid, they lost power, they lost television stations, they lost like all the things we rely on as like our backups. Some people were able to go and put Meshtastic nodes at the top of the mountain, something that looked more like this or heavier duty than that. And it ran off of solar. And then they handed these out to the people that needed to be points of contact and be able to communicate with each other all over town. And since Asheville's in like a valley, people were reconnected and were able to get messages in and out, be able to get connected to maybe an internet connection through this, to be able to get a message out over the internet as well, that kind of thing. Yeah.
So search and rescue, so for example, remote areas like natural park search and rescue.
Yes.
This would be a
Yeah.
really good use case.
Yeah, and we've got a node at Chestnut Ridge Park, and we're hoping to be able to get nodes elsewhere in Chestnut Ridge Park. Right now, we're on the toboggan run, and that view from the toboggan run is essentially blanketing LoRa all over in the entirety of the Buffalo region. So if you have access to see Chestnut Ridge Park, then you have access to the mesh network and communicate with about 200 meshers in the Buffalo area right now.
Probably would have came in handy a week ago when Verizon went down.
We were all saying, hey, yup, we're up.
I was like trying to figure out like, how do I tell my wife what time to come pick me up from work? Oh God, this is going to be a thing.
Yeah.
I end up having to ask somebody to text her, basically. Yeah, but yeah.
Yeah, it's as we experience outages and things like that, and we don't know why Verizon went down, did we? Did we hear why?
Verizon hasn't
All they said was software.
said, yeah, that's no real answer.
But we know Meshtastic was doing quite well in the Iberian Peninsula when Portugal and Spain went down a few months ago. We know Meshtastic's being used in Minneapolis. We know Meshtastic's being used in Iran. So there's areas where networks are taken down intentionally in order to prevent communication, that kind of thing. It's nice to know that you've got an option that would allow you communication, but I will not say it's foolproof. If the U.S. government wants you to not use Meshtastic, then they'll make it a licensed spectrum and say you don't have the right. So I'm not advocating that it would be a technology for circumventing the government or anything like that. I'm just saying there's areas where they are using it in that way. So.
Can I actually ask a question on top of that? So you had said before that if somebody wanted to, they could, in theory, block a particular part of the spectrum, but because of this, the dashes.
I'll step back, yeah.
That this wouldn't be an issue because.
It's not as easy. Yep.
Yeah, but so like, would it just be somebody basically finding like one thing and just blocking it out? Basically, is that?
So to give you an example, on the if somebody were to generate a signal in that frequency, they couldn't just generate one signal. They'd have to generate one of these symbols, and that actually happens when you've got too many Meshtastic devices. They start, occupying the spectrum and overwhelming kind of the messages, because really only one message can kind of go out at a time. Everybody's listening for a message, and then they're sending a message when they think it's their turn. But when you overwhelm, you got too many, then you might have kind of gobbledygook in that area. But theoretically, you can move to another preset And if everybody want to be on a different preset, then whatever is getting you here isn't going to get you there. Just like you could change channels on a walkie-talkie if somebody's using that frequency, that kind of thing.
Cool.
Yeah.
What capabilities do you have if you have a radio to determine where the source of a low rel transmission is emitting from?
Yeah, so you could definitely fox hunt. For instance, just like even with Bluetooth, I've used receive signal strength indication and walked around and entered this room. Oh, no, I'm getting further away, hot and cold. And you could, with some very high-end devices, you could triangulate with multiple antennas and really pinpoint. So yes, you can find the source of a low-rel device.
And frequencies things at that frequency won't transmit through your body very well. So you could put your antenna close to you, and then if you get a strong signal, it's in front of you. And so
You
you
can
can
be
just,
the mountain.
you can be the mountain, yes.
Interesting.
Yep.
You can do that for
Body
it works.
lock.
It works good for Bluetooth because you're really a lot of water, and Bluetooth is Wi-Fi. So
I'm mostly alcohol ruined.
I think the term is ethanol fueled.
Yeah.
All right. So there's different roles of operation for these Meshtastic nodes. Most of the time, you're going to use client as your device role because it's going to relay messages and allow you to send and receive messages. So Meshtastic kind of creates ad hoc mesh because every device, the one I'm wearing here, this is going to participate as a relay. And then this one's going to participate as a relay that's maybe on top of a skyscraper. So as I move around, I might be enmeshing somebody who wouldn't been able to get connected before. And that's kind of a good thing. But sometimes people, when they're traveling with a node, maybe they don't want to be relaying messages. They just want to be sending and receiving. They want to participate in the mesh that exists, but they don't want to extend the mesh. So there's other roles like client mute, routers, which would be infrastructure type nodes that would be really critical to the mesh that are going to be moving a lot of messages. And then, of course, client's the most popular. And so here's some deep dive on those. So client is really when you're connecting to an app or a standalone device. It's generally used for individuals needing to communicate over a dynamic mesh network. So as you move the node, your mesh network's going to evolve and change, and it'll send, receive, and relay. Then we've got client mute. And this is for a standalone messaging device or an app-connected device. But this is for individuals communicating over a robust Meshtastic network with better positioned nodes close by. So for instance, if Bithaven had a node in the window, there would really be no need for me to have this one on client. I'd have that one in the window maybe as a client, and then I have this one on client mute, because I would hate for a message to make it into this one and this one retransmit. And really the one in the window should have done the retransmission. But for all you guys that are just getting started, especially here in Buffalo, we don't have enough nodes that it's really going to kill for everybody to have client set up. Client is good.
Does it have the ability to auto detect if there's like a stronger, and it should just go into the mute mode?
Yeah, I don't talk about it in this deck, but it does not change the mode for you. But one of the things about the meshing algorithm here is it's actually going to be, the nodes are going to be listening to the received signal strength indication, and the node that hears the lowest received signal strength is going to be the one to rebroadcast first. So you can imagine if I'm this node here, and I've got a node here, and I got a node here, they can all hear the message. And it's all moving at the speed of light, right? But since this one hears the message a little weaker than this one hears the message, this one is going to wait in terms of relaying that message until enough time has elapsed. This one's going to have less time that needs to elapse because it's got a lower signal strength indication, so then this one's going to push it out. That way your furthest away nodes in RF speak are going to be the ones to rebroadcast. Now, your edges are hopefully the ones that are rebroadcasting, and it might go around an object because this is reached the other side, and maybe it can reach other nodes that are physically closer but RF wise are further away.
And that's done to, I I imagine, expand the range in which they can go without taking a hit on the one for the hop, right?
That's right, because if, let's say we've got 7 hops, I've got more than 7 nodes here. If every one counted as a hop, we'd have a very small mesh. But if the furthest away node that's hearing it the least retransmits first, and then if nothing hits out there, then something closer would retransmit, and then something closer still would retransmit. Now you get the best chance of the mesh bubbling out as big
How
as
do you
possible.
avoid collisions?
Yep. Essentially, with this timing, that's going to be part of it. The nodes do have some sort of like clock, and they do kind of synchronize. If there's a GPS-based node, then the clocks get more accurate. If it starts to retransmit a message or transmit a message and hears, oh, somebody else is talking, it's going to stop. There's multiple attempts as well. So they're all going to try and not step on each other's toes. And we avoid collisions generally by not having too many infrastructure nodes. This router, for instance, as soon as it hears a message, it's going to rebroadcast that message. We never want 2 routers near each other. We might have a router in North Tonawanda and a router in Orchard Park, but we wouldn't want to have 6 routers in between, because they'll all be blasting that message as soon as they receive it, and they're going to step on each other's
2
toes.
routers in the same pond, basically.
Yeah.
And where you want to hop from pond to pond to pond until you
That's
find
right.
that you've overstepped, and then you go back and then you hone
That's right.
inward on that pond.
Yeah.
And in that analogy that you just gave, would you want one, like a router in Buffalo then, like in the actual city itself then, because like, I'm just thinking like geographically, like, you know.
So to date, I haven't deployed any routers, and we have a thriving mesh with hundreds of nodes and that kind of thing. We might find that somebody has deployed a router, but if somebody deploys that router in their basement, then that router is going to hop gobble. It's going to essentially consume that hop, and it's not going to go anywhere. So maybe it heard it, it rebroadcasts it. Maybe my original node that sent the message hears that the router rebroadcasted it, but it doesn't get out. So these are really more strategic decisions. And so I'd say if you're thinking you've got a good location for a router, loop me in. I've helped to build out this Meshtastic network from about 4 or 5 nodes in Western New York at the beginning of 2025 to now over 200 through having meetings like this and by personally giving out, building and giving away nodes. I've probably given away 70 plus nodes to people. So my dream of meshing down the street to my buddy in Eggertsville from Snyder was reached. It took a lot of effort. But then the next step, it's gone pretty well. Yeah, and I've done that with the help of clubs, community organizations in the area, like BARA, the Buffalo Amateur Radio Repeater Association. We've got a node in Kimball Hall where they've got their repeater, which is serving the Western New York area for amateur radio. We've got the node in Chestnut Ridge Park. We're working to get nodes elsewhere as well. There's nodes that I didn't place, but that people that I know have placed all over town in strategic locations. Williamsville is particularly well covered by a resident of Williamsville Towers. You can be
tower on the top of that building too.
you can be, and this is just in an apartment, but you can be inside of the original pancake house and be meshing away. It's amazing. I never thought we'd be at that point, but we are. Yeah.
Is there a risk of pirate routers then, or spots popping up that are routers in the middle, as it were, that can misdirect these packets on you?
Well, I think because it's RF, all of these devices, it's spreading out in space and time in all directions. If somebody errantly places a node in the wrong mode, it'll negatively impact the mesh, which is a shame. Usually there's not usually it's a node somebody set up 3 years ago when Meshtastic first came out, and they thought that they were helping, and now they're not helping. That's what I think.
Did they add a black holing mechanism for places like that?
You hear that? He's wondering if there's a black hole
There,
method.
there.
Black
Okay,
hole in it.
is there black holing? So one thing I will say is if you see a node out there that is not helping your mesh, you can block that node. And so now my node is not going to retransmit any traffic that comes from it, and so it'll participate less in the mesh. Yeah. All right, and then we talked client mute sensor. So you've got maybe a gate on your property that you want to get that information into your smart home, and you want to know when the gate's been opened or the gate's been closed, or you want to know what's the flow on your natural gas because you're the gas company, or you want to collect temperature data or smog information. Well, these sensors are great because they can participate in that mesh network, the community mesh, and get that the sensor data where it needs to go. These are going to send, and then they're going to receive and relay only when they're awake. So typically these devices, you want to get much longer run times out of them. So they're going to, when they're ready to send a packet, because they've got that sensor reading, they're going to send it. And then if they hear anything in that time that it's awake, it'll relay and retransmit and receive back as well. What's that?
How much do these devices cost?
So you can get some nodes. I just saw something that people can build their own nodes if you do it in bulk, and you order the PCBs off the internet for as little as $5. You can buy a pre-made one, and I've got some in my bag here. Oh, I'm so sorry. Excuse me.
Sorry, I was
Let me pull one out so you can see what it looks like. But you can get a node for like $14, $15 before shipping, and then they've got some nodes that are like $200. Just depends on what you're trying to do. But so these are two little nodes from Seed. We'll talk more about the details of those, and I'll talk to you a little bit about options and price and that kind of thing. Yeah. All right, and then we talked a little bit about router here. So it's an infrastructure node for extending network coverage by relaying messages. We really don't want routers on buildings. We want routers on mountains and on antenna towers on top of mountains because they're going to relay with priority. Otherwise, client is going to relay it too. It's just routers are very good if you're trying to connect two disparate meshes that wouldn't otherwise be able to get connected. That router's really got to be in the middle to make that traffic happen efficiently and effectively.
Can you please briefly restate the difference between client and client mute?
Yeah. So client mute is going to send and receive, but it won't relay. And so if you've got another relaying device nearby, you wouldn't need to bother with having your device relay. There's something called a trace route you can do on the mesh. So when you send a trace route, if you notice, oh, I got like 3 nodes in my house that are relaying this message before it gets to me, but I want the one in my attic to be the only one, set those other ones to client mute, and then you're in good shape. I operate some BBSs and bots on Meshtastic that'll auto-respond to messages. Those are all client mute because I don't want them relaying traffic. I want them participating in the mesh as senders and receivers, but not as relays.
So then the client mute would have a lesser power consumption?
A little bit.
Is that correct?
A little bit, yeah.
Okay.
Yep. So you might get a little bit more battery out of a device like this if you had it in client mute.
Because I'm thinking about, for example, leaving a client mute device with someone from a vulnerable population who would not want to be relaying and broadcasting. So that is the exact thing I was looking for. Thank you.
Okay, yep. And then client base. Oh, we talked about router, relay with priority. And then client base, if you guys have seen this meme, he's like vibing, he's like so happy. It behaves like a router, but for your favorited nodes. So on this device, you log into it and you set, who are my favorites? And I say, oh, I want this one to be treated like a router from my attic node. You get exactly what you're looking for. But to the greater mesh, it behaves like a client. So it's going to do everything a client would do. It is essentially all the pros of router without the cons of router for your own personal slice of the world. And so what kind of range can you expect? The typical stock range node to node is going to be about 1/2 mile to 2 miles on the ground. Height is might, so with good line of sight, nodes can reach much further with a single hop connection, hitting well over 10 miles. For instance, this node in a upstairs window was often getting packets from in Harlem and Maine area, Snyder, where I'm located, was often getting packets from about 21 miles away in South Wales. South Wales is a little higher up on the hill, so we've got better line of sight. And then, but as part of a mesh, 3 radios could easily reach 15 to 30 miles on the 100 milliwatt that this is pushing and stock antennas. And today, Buffalo is achieving a stable LoRa mesh from Orchard Park to North Tonawanda, often temporarily connecting to North Niagara Falls, Rochester, and Toronto by LoRa as well. So if the RF is really good that night, usually right before a storm, the cloud covered, like for some reason the radio waves bounced just right. And I was talking for about an hour I was getting node announcements from Detroit, and I was talking for about an hour with London, Ontario. So that's not an airplane when you can do it for an hour. When airplanes come by, you'll get linked up as well down to Pittsburgh and that kind of thing.
Because it bounces off the metal of the plane.
Or sometimes people
Or meshing in the plane.
bring a node on the airplane, which I wouldn't advise.
Yeah, I was about to say, that seems like a TSA, I'm gonna jump you at the line thing, but yeah.
I haven't had any problems. I've brought my node to Europe. Most glorious thing I've ever
They
experienced.
don't know what it is. They don't know what technology is, so.
That's fair.
Most glorious thing I've ever experienced for Meshtastic was meshing in Edinburgh all the way to Glasgow in Scotland from sea to sea across the entire country. Yeah. All right, so how does it work? Well, you need 3 things. You need a Meshtastic node. That node could be something like this T-Deck, which is an all-in-one node that combines the interface and a keyboard and LoRa technology, or it could be a phone app you could use, and then you need somebody to talk to. And then what are the different hardware components? Well, there's essentially a microcontroller with a LoRa radio. Generally, it's a SX1276 or SX1262 transceiver paired with an ESP32 or an NRF52 MCU. And so there's some key differences for the hardware. ESP32 based units offer Wi-Fi and Bluetooth, as well as tons of I/O and fast dual core 240 megahertz MCU. This allows cool features like a fancy GUI, but that's all like the expensive battery usage. So it's going to pull a lot more battery. Typically, you're going to get with the same battery about 1/5 to 1/10 the runtime for a ESP32 node versus the Nordic and NRF52 base nodes. Those have Bluetooth and single core 64 megahertz MCU, but they consume a lot less power. So those are what you're looking for remote, battery operated, or solar nodes, because you're going to get more life for your charge. You don't want to have to carry around a huge battery to be able to use your Meshtastic device. You want something small like this. And so the Meshtastic firmware provides up to 3 ways to connect to the node. Serial when plugged into a PC or a phone. The device will act as a serial port, and you can send serial commands to it. If you've got Android, it'll work right over the cable. iOS doesn't do serial right now, but your laptop will be fine. And then, or Bluetooth. Everything works with Bluetooth, so that's great. You'll get a pairing code either on the screen of the device, or you'll put in the default pairing code. And then Wi-Fi devices on the same network can connect to and use the app or web interface as well. Once you're connected, you can start chatting or using plugin applications that will communicate over the Meshtastic network. And here's a little bit about the different nodes. So the one on the top left, that's my kind of like ride or die, my first node. It's NRF52 based. It's IP65, so it's water resistant. Yes, this has gone through the washing machine. Don't put it in the washing machine because it's not waterproof. It's water resistant. There's one like it. This WizMesh tag. This is IP67, so this is much more waterproof. This can be dunked and stay under for 10 minutes, and it'll be fine.
Don't run it through the dryer.
Yeah.
Is it called whiz so you can drop it in a toilet? The nomenclature.
I don't know. That's a good question. And then there's the WIO tracker, also from Seed, that makes this one. That one's got a little screen and a little joystick, external antenna. And then this is one of the coolest nodes, I think. This one's actually a Qi phone battery. So you can actually just pop this onto the back of your iPhone, and you now have a full charge for your iPhone. Or if you don't take advantage of that luxury and you leave this around, you're going to get about 2 to 3 weeks out of this, because it's got a 5,000 milliamp hour battery, whereas this has a 500 milliamp hour battery. So this gets about 2 to 3 days. This gets about 3 weeks. And these ones are about $50. Maybe you can get as low as 40. Maybe you pay more like 60, depending on how much of a rush you are. And I'll just call out, I've got some coupon codes on my website, buffalora.org, so you can check that out. And it helps me to put nodes in the area, so thank you. And then there's infrastructure type nodes. So you got this Seed solar node. This is what we've got at Chestnut Ridge Park, the one on the left there. It's fantastic. I'm using the stock antenna, and we're connecting all over the region. You can upgrade the antennas and that kind of thing too. The one below it is a 1 watt node that maybe you would put in your attic if you had a nice eave that you can put an antenna in. To the right of that is the Station G2. That one's probably one of the more expensive nodes, but it's really one of the first 1 watt nodes. That's what's running SnyderMesh World Headquarters in the attic. And then we've got this Beacon Solar Meshtastic node from that is on the site from Altavox. That is a bit more, tactical, military, rugged, so you can just take that out, and I think it's got 2 solar panels on it, so you can just put that on your hillside or whatever when you're out and about and trying to give comms to people below. Then, of course, and those $50 to $200, depending on which node. The one on the upper left is like $100 plus shipping. The one on the lower right's like $130 plus shipping. The one on the lower left is brand new, about $60. It's fantastic. And then the one on the upper right, I think, is a bit more expensive. And then there's do-it-yourself. So you can build your own nodes, like I was mentioning. You can print a PCB and get a batch of those at about $5 a pop. You could build your own Meshtastic nodes. This little guy's $14 on Seed's website. The rack ones, upper left, are about $35. Lots of I/O on those. The ones below that is $50 for a pair or two. And then this is a inexpensive homemade outdoor solar node that uses this chip inside of it. I just soldered this 4 solder joints in parallel with the battery for a hardware store solar gutter light. And so you can use an existing enclosure that's already water resistant and throw a node in there and you're up and running.
Are you going to be at D-Sides?
What's that?
D-Sides are HackerCon in June?
Yeah, June 6th.
I'd love to come.
Yeah, we'll talk
Yeah.
after this.
Great.
I was thinking it might be fun to have some Meshtastic stuff in the CTF.
Well, they've done SDR stuff for Rochester's mesh, stuff as well. So like they encoded pictures in the data stream. So when you looked at them in SDR, you could see the picture go by.
Okay. Very cool.
Full waterfall.
Yeah, very cool. Yeah, I've got a RTL SDR, so I've seen the waterfall and that kind of thing. It's pretty cool. So you bought a thingy, so now you got to program it, right? So when you assemble it and you get everything put together, one very important thing, make sure your LoRa antenna is connected. Do not ever operate your Meshtastic node without the LoRa antenna connected. You'll fry the chip, because all that energy is trying to get pushed out to radiate into the world. If there's nowhere to radiate it, it starts radiating your chip, and your chip will burn out. But you'll see it might not be running Meshtastic firmware. No big deal. We'll get Meshtastic on there. You just need to program it. You can flash it. They made it easy. Everything connects over Bluetooth, so you just plug it in. When you plug it into your computer, in your device manager, you'll see that the COM port will pop up. That'll let you know which one is the Meshtastic node. You might need to press a button on there to get it into the right mode for flashing. or you can use the different apps. But you'll see instructions in the app. And if you need a driver, there's drivers out there for Linux and Mac. And then you go to the flasher.meshtastic.org website and you flash it. And so you want to select your target device. What does that look like? On the left, you'll get a pictorial of what all the devices look like, and you can select the right one based on what you have. There's also an auto detect button. It might be able to find your device for you. And then you select the firmware version that you want to run. The stable or beta firmware is at 2.7.15 right now, and there's an alpha version at 2.7.17. If you're familiar with the term Konami code, you can type that on your keyboard when you're on this website, and it will maybe show you another version of the firmware that's available that's a little bit more pre-alpha. And then click flash. And then you might get prompted to select your COM device. Remember, we noted which one popped up when we plugged in before, and you just select that. And then you're running Meshtastic firmware. Now, when you first log in your device, you're going to put in that pairing code that's on the device on your phone, or you'll connect through the serial. And you might get asked some questions like, what is your region? So you'll say North America, that we're complying with US laws. And then it's going to default all the settings that work for Buffalo for this area. So you don't have to change anything, but you will see that there's different channels that are available. And so out of those 7 channels, you could set up encryption keys for all of those if you wanted. And the primary one is AQ == so that you can communicate with the greater mesh. There's going to be one default channel that everybody can talk on. But you don't have to use that channel if you don't want to. You can go on your own channels. Your device will retransmit neighbor packets whether you're on a channel or not. So it's going to not look at and inspect those and decrypt those packets to retransmit. It's just going to hear them and retransmit them.
So if we just wanted 6, 7, 8 people, whatever, to be able to communicate directly with just them, we would change that up there then.
You would add a channel 2, and then you would add your encryption key, and it'll propose one for you, and you just share that with everybody. Here's what that looks like. You'll be able to press a button and get a QR code, then you can share that, and everybody that scans that QR code is now on your encryption key for that channel.
And by adding a secondary, you can still participate in the original one too.
That's exactly right, yep.
Cool.
Yep. One thing I will call out, that primary channel can't be disabled, and that's where all your telemetry data is shared. So other meshers will be able to find you. They'll know you exist if you are on that AQ == encryption key on that primary channel, and your GPS position and that kind of thing. But you can set a level of precision. So if you want to share your GPS position but show that you're somewhere in a 1.8 mile bubble, you can do that.
Does this product need one of us to get a room at ECMC that's on a high floor? Like right at the middle of Western, smack dab in the middle of Erie County?
Let's talk afterwards. Yeah. And I did want to call out, there's other radio presets. We talked about those on that curve. So here's the facts about those radio presets. Short turbo, 21 kilobits per second versus very long range slow, 0.09 kilobits per second. They pick something that kind of meets in the middle, that pushes nice and far, and covers communication pretty well. But you'll see an option when you're setting up to select that preset. Just keep it at the default long range fast.
So I have a question. If you set your radio up to be faster or slower than everybody else,
You're in a different mesh than everybody else.
but then you could use that to do a long range connection that then talked on one of the
If you're
other channels.
faster, you're going to be a shorter range connection.
Okay, but
If
I
you
mean-
went for ultra slow connection, then you could do a longer range connection. Yeah.
Okay, but in general though, if your radio is doing one of those,
Mhm.
you'd have to connect it to a second radio doing something else.
And there's a way to do that now, which is magic. Yeah.
Okay.
Oh, there's like a gateway between the two.
We can bridge mesh networks now, yeah. So for this audience especially, I want to call out that one time at DEF CON, a researcher demonstrated a way to forge node information under certain conditions, causing downstream issues in channel messaging. they never actually changed. They put essentially these ninja icons next to Meshtastic users' names. So they listen, what are all the Meshtastic users I can hear at DEF CON? And then they said, I'm going to broadcast that exact same name, but I'm going to, and same public key, not the same private key, but I'm going to rebroadcast with this ninja icon. And so encrypted DMs and private keys were never compromised. The specific issues already been patched, and the event highlighted areas for future improvement, including user experience, identity verification, and message signing. But so be aware, and the way that they're able to do this, you would, if they wanted to, you can go on there and you can say you are whoever you want to say you are. But if I push that same message of I am whoever I say I am 800 times on 800 different nodes, then guess what? That node that was originally representing that identity would fall off the node database because the node database is filled up too much. So they've made some improvements to try and address that. And if you guys have a appetite for this type of stuff, there's bug bounty programs, that kind of thing. So get involved. Maybe you can make Meshtastic even better. And then the latest improvements in the firmware, 2.6 and 2.7, the radio utilization. They came out the next hop routing for direct messages, which helps reduce utilization because there's an assumption that if I got a message back and acknowledged through a specific route, that now not everybody has to retransmit that message, just the ones on that route retransmit. And if it fails after a certain amount of time, then it goes back to a managed flood where now the whole flooding would happen based on lowest RSSI. Meshtastic over LAN via UDP, which allows mesh bridging across presets without a hop cost. So as long as you have the same channel name and channel key on a node that's on a medium fast and a long fast, technically those two meshes can work together. And so you could have medium fast for your local area, then you could long fast as a long haul to somewhere else and have medium fast there. And now these two medium fast mesh networks that couldn't talk to each other normally would be bridged together. There's zero cost hops between favorited infrastructure nodes, which enables larger meshes. Before, you're stuck at 7 hops, but if I set this infrastructure router and this infrastructure router as favorites to each other, anything that passes between them, it's assumed shouldn't count as a hop cost, which is pretty cool. Telemetry is now disabled by default, which reduces utilization. One of the biggest complaints about Meshtastic, which has led to other projects kind of spinning off, is that these my node exists, here's my name, messages that aren't user generated can sometimes consume 40% of the mesh network's traffic. And if you just disable that or get it to be much more sparing, then you can accommodate more actual real user traffic on the mesh. And they've deprecated the repeater device role, which leads to clearer topology. It's kind of like router, but it was invisible to the mesh. So you don't know that it exists, but it just repeats messages. And that becomes a problem when somebody's got a repeater in their basement. All right, user experience. They've come out with a Meshtastic user interface, MUI, for standalone devices, which is GUI and pretty and like that. So you can message from a standalone device and not need to have your phone. They've got an ink HUD, low power, always on user interface for e-ink devices. This is kind of optimized to work on e-ink screen. You don't want to have as many screen refreshes as you might be comfortable having there. And then base UI, they've improved the user interface on devices like this that has a more unified and capable end user experience. Now you can actually author messages, not just select from a list of canned messages on single button devices, but you can navigate a keyboard kind of with a single button or a few button device. And then they kind of unified the MUI and base UI with UI switching. So you can actually have, and I've got an example of this. This is that, it's coming. But you can see what the interface would be like on here, and you can get it on a device like this, and then you can swap back and forth to that graphical user interface. I might be low on battery at the moment. Kind of like a BlackBerry, but just for Meshtastic, yeah.
The keyboards, there's been people adding keyboards from BlackBerries from certain models.
And here's that user interface, just like you'd see on a device like this. But you can do a lot more with it now, which is pretty cool.
Well, that was my question too, like, can you, how accessible is the new interface? Is it, can I send it to a 40 cell braille display?
Because this is, I'm imagining with the 40 cell braille display, you could write a program and put it on the firmware for this as a plugin, and the community would love to have something like that, I'm sure. And then this has the I/O that would let you connect to that. If you were to if you were to be able to build a braille display that could connect over UART serial connection,
Yeah.
then you can connect to this.
Well, they tend to be Bluetooth,
Okay.
so,
Connecting it over Bluetooth might be a little bit more challenging, but not impossible. Yeah, good question. And then there's been some security improvements, fixes. Now, in light of DEF CON, there's manual key verification. So if you want to make sure you have the right person's key, because you've met them physically in the meet space, and they can give you a 6-digit code, you can key it in, and now you've validated that you guys are the same. You're talking to who you think you're talking to. There's also an issue, a bug at around 2.6, where there was low entropy key errors, where this manufacturer and other manufacturers were essentially creating a image that they flashed to all the devices to get you Meshtastic, and there was about 40 keys out there. Everybody had the same public and private keys. Now they've changed it so that they will alert you if you've got a low entropy key, and now keys are generated after you've set your region code, so it's not something that comes on the device. We don't want it to come on the device. We want to generate our keys after the device is built up. So if you're on 2.7.17 or 15, you're not going to have those issues. Make sure you just get the latest firmware. You want to avoid the sins of the past. And then that spoof and flood fix, duplicate public key messages. So you'll get notified if you've got a duplicate public key of somebody else, because there's a risk that you have duplicate key as them on your private key side too. You can also block DMs with by default now in the latest firmware, they block DMs between non-PKI nodes and PKI nodes. So if you're on the latest firmware, you won't be able to talk to the older device users. They just got to update their firmware. And then favorited nodes are now retained when clearing stale nodes. So part of that DEF CON issue was they would push 800 different nodes in, and your node would fall off the list because it was not being retained, because I heard that one 800 ago. I don't need to keep it anymore. If it's favorited, if you've ever messaged with them, it favorites it. Now it keeps it. So no one can kick your friend's node off of your list. If you unfavorite it, that's a different story. But if it's favorited, it won't be kicked off the list. So now you might see two nodes that look like the same name, and one has a little ninja emoji, but you'll be able to discern, oh, there's a problem here, instead of just thinking that someone's hacked them. And what else can we do with Meshtastic and LoRa? Well, MQTT means we can connect those Meshtastic devices to a Internet of Things messaging protocol and pass those messages over the internet. So there's a default Meshtastic MQTT server, and so if you connect to that, you can mesh with people in Rochester or across the whole country. Don't sign into the root topic for the US. There's too many nodes. Your node's probably going to crash because there's too many messages, too much going on. But we've got a really nice one here in Western New York, and I can share those details if you want. I personally love connecting a BBS server to my Meshtastic node. And then that means that LoRa users and MQTT users can now get access to advanced messaging services like email type messages where I will store and forward those messages for you. So when you connect a node to the network and someone's left you a message, it will now rebroadcast it to you so you can get it. You can play games. You can connect to my LLM and you can ask it for its favorite chocolate chip cookie recipe and get that over Meshtastic. I've got a offline KeyWix implementation of Wikipedia. So even if we lost all internet, you can still get access to the summary of Wikipedia through Meshtastic for any topic that you want over your Meshtastic node. What's that?
How big is that? That's gotta be huge.
It's not that big. It's like 10 gigabytes.
Oh, okay.
It's really not that bad.
It's all text.
It's
I
compressed.
I left off all the pictures. Yeah.
And it's probably compressed.
Not really, no.
Okay.
Yeah. And then on LoRa, you can run other firmware. There's something called Reticulum Network Stack, which can use our nodes, which are the same hardware we see here, just with a different firmware, connected to a computer, and it operates something like an alternative to the internet. RNS can work over the internet. It can work over packet radio. It can work over carrier pigeon. It can work over QR codes that you print out and hang at the town square. And so with Reticulum Network Stack, you can do all sorts of different services of like websites and messaging protocols. And then there's also this other messaging platform called MeshCore. They came out because there's just too much noise on the Meshtastic mesh in England. And so they had a very robust Meshtastic network there. And some people that were interested in maybe being developers, not in a fully open source project, but be able to take it more into like the MIT license where they could maybe turn a little bit of a profit on their development effort. They offer a messaging platform that's known for each device never sends telemetry. You have to intentionally tell it to send telemetry or intentionally tell it to send your node announcements, and it's called adverts. And so that means there's none of that like background noise on the network of nodes describing themselves to other nodes. Or
Just thinking of ARP, just ARP is how much your network noise on a wired
Perfect.
network.
Mhm. Well, and so MeshCore essentially it only talks and relays when there's an actual person sending a message, but it's not as good in that for ad hoc networks, dynamic meshes. This is really fully infrastructure based, so you have to flash something as an infrastructure node with infrastructure firmware, and then a client as a client node with client firmware. The client does not relay messages. So somewhere like Buffalo, we don't have the density to really achieve that at this time, and Meshtastic has been essentially implementing similar functionality that achieves the benefits of MeshCore, so we don't necessarily have to go to MeshCore to get those benefits. MeshCore is in a way making Meshtastic better because it's challenging them to clean up the sins of the
It's
past.
Mr. Ed, and Mr. Ed will never speak unless he has something to say.
Yes. And then I'm SnyderMesh from Buffalo. So what's that all about? Well, Buffalo started as SnyderMesh, which was I was just trying to build a Meshtastic network in Snyder, and I got 2 nodes and I walked around the neighborhood and I was like, oh, we got a lot of Snyder here. I can reach 5, 6, 7 streets away. What do I need to do to make it more robust, more filled in? But eventually we kind of outgrew Snyder. We are reaching much further now. So there was essentially 4 or 5 nodes after driving all over town, trying to meet all the meshers that there are on radio. Now we've got about 200 in the Western New York area since February of 25. And so please go to my website, buffalora.org. You'll get information about the mesh in Western New York, information about monthly meetups. You can connect with us on Discord, different news and updates, build guides, walkthroughs, device ratings and deals, coupon codes, and then you can contact us as well. And then, are there any questions? Oh, I want to call out KC9MNE, originally created this presentation material and allowed me to use and modify.
about, can you get it to interface with like home automation?
Absolutely. So Home Assistant connects with MQTT, and MQTT connects with Meshtastic. So you can have Home Assistant link up with your Meshtastic, or you can plug a node into Home Assistant, and you can write a Python bot that would talk to Home Assistant if you want. That's what's going on with the various BBSs I'm running. They're either in Python or Rust. I didn't write any of the bots myself, but I've shared a lot of feedback with the developers, got to make changes. Very exciting community. They want to do a lot of cool stuff, and they are.
So I don't know if you mentioned this,
Mm-hmm.
because I got here a little bit late, but low raw, or you're saying it as more of like LoRa, but I'm used to hearing of it as
Low
low
raw.
raw.
Yep.
Because what it started with was like the 1930s, the way the military used to talk to submarines, and it stands for long range.
That's right.
And so there used to be, like, north of Syracuse, there was an antenna that would talk to submarines that was on the, like, 2.3 megahertz frequency range that the military would use.
Thanks, Ro.
So,
I'll tell you later.
I apologize if this is a simple question, but so you've got two nodes,
Yeah.
and you want to send a message from one to the other.
Yes.
What does the addressing scheme look like? Is that something you set up when you flash the firmware?
Yeah.
Does it announce its name?
Why don't we log into the app, and we can send a Meshtastic message right now. So right now I'm logged into the Meshtastic app. You know what? I'll log out. Let me. Okay. So we're at Connect New Device, and I'm going to go to Bluetooth, and I'm going to search and find my device. I've already paired it.
Okay,
And just click into it.
You're connecting with it over Bluetooth?
Over Bluetooth right now, yeah. Or I could just as easily connect over USB. And so here we've got the map, and this will show the nodes that I'm enmeshed with right now. This particular device does not have Wi-Fi on it, and I haven't been connected to Wi-Fi in a couple weeks. So pretty much everything you're seeing here are Meshtastic nodes that sometime in the last few days I've connected over RF to. So I could theoretically message any of these nodes that are nearby. There's different configuration settings that you can change, different module configuration that you can change. But if we wanted to message, I'm on the primary channel, or there's also a channel called that I've added called Long Fast. If you're on an iOS device, they have this primary channel that is an empty name, and so I've got that set up so I can message over MQTT. You can essentially turn on MQTT or off for every channel, and then I also created Long Fast, which is I don't have MQTT turned on. It's just a quirk of iOS that I can use both a primary channel and long fast, because in the code primary is redirected as long fast, just so you're aware. But if we wanted to, we could say hello meshers from Infosec 716, and I just send the message, and then I should get some sort of little I think I'll get some sort of call out here if the message was not received, but I think that at this time this message did make it out over the mesh, and then maybe we'll get a response. I'm going to go to the primary channel, which is MQTT enabled, and maybe this will get out. Hello meshers. And let's see
So this is like a public unencrypted channel, these guys? Or these are
I'm on a public unencrypted channel at the moment, yep. Oh, maybe one of these received the message.
So it just
Oh, so I've got two new messages here. And I'll come down to the chat and go to Longfast. And you see that both of those made it to the Longfast channel.
okay.
One was sent also with MQTT, and one was sent without MQTT. That's all it was. So I represent that in two different channels. So if I want to send a radio-only message, I have that shortcut to be able to do it.
Okay, so that's broadcasting to everybody, but you said it also has DM functionality?
Yeah, so if I wanted to, let me find my D63A, and I can send a direct message. Hi, as a test. And I sent that. And oh, there we are. We see this little 3 dots waiting for delivery. And I'm going to pull up on my phone here and see if we get that message.
But I think what Matt is wondering is if you can address to a node that isn't like one hop. Like can you give it a route to a node rather than letting it just float?
So as soon as any node that's the intended recipient receives that message, it sends an acknowledgement back. It says, got it.
Okay.
So if that, for instance, that message could have traveled over 7 hops to get to my device, or it could have traveled 0 hops to get to my device, but it's going to automatically be managed. You don't have to define the routes. You don't have to know what nodes you're trying to hit to get there. It has it all baked into the algorithm, and then next hop routing is going to help pare down who should be listening to forward it on. When those nodes hear that, oh, I should forward that on, then they immediately will forward that message on the hopes that then the second hop, up to 7 hops, will be able to hear, okay, I'm next. And then if that breaks down and no one receives that message, then the whole mesh will manage to flood it out, where whoever has the lowest signal strength will try and send that out, who received it last.
So if the person you just DM'd wasn't available,
Yep.
and let's say their device is just dead or something, battery's dead.
If the device's battery's dead, then they won't get that message. It'll say max number of retransmissions.
And it just kills it.
And it's just dead. But now well, I didn't make it. I got to find some other way to reach them.
Yeah.
Maybe I got to climb the mountain, whatever I got to do to try and get my message out.
Right. Got it. Cops confiscated it. Got it. All right, thanks.
You do have a fan that said they replied on long fast.
Yeah, I saw, I see that on the phone here. So let's see. We've got shout out SnyderMesh, hello, the 2 messages I sent, and then great job on presentation from MDoc. Thank you, MDoc.
Doesn't look like anyone responded on the general one, I don't think.
Here's what I'm thinking. So this node is not on MQTT right now, and this is the one we're showing here. So because of that, I'm just not in good Meshtastic LoRa connectivity from this particular location. Maybe if we got a node in the window, that would fix all of
I'm
that.
gonna try and respond.
Deal.
See.
Done. Say no more, Phil.
I actually was going to talk to you about putting
Yes.
an APRS node
Yeah.
or an APRS radio to listen to the airplanes.
I mean, we could
Yes.
do whatever we
Because
want.
we're facing the airport. If we did APRS from here, we'd be able to hit everything up to like 30,000 feet going towards Syracuse.
So you're a ham guy?
I mean, well, there's a lot of ham people in here.
Oh, great. So you know N2UGS, Jeremy?
I do not. I'm not radioactive in Buffalo.
Okay, wonderful. All right. Well, there are projects out there for APRS to Meshtastic, and I know you mentioned airport ADSB
Yeah.
to APRS to Meshtastic. So
Okay.
we've got a lot of cool stuff going on in the ham radio space. We can with my bots, I can link up JS8 call or WinLink or any of those apps,
Okay.
and I could forward messages back and forth.
Yeah.
It would be incumbent on me running those bridges to make sure that anything going out over licensed spectrum is unencrypted, and then it'll certainly get encrypted once it leaves licensed spectrum and goes into unlicensed spectrum.
Okay.
And there is a ham operator mode,
Well, I was
but
going to
you
ask.
got to
You
play
said
by
there
the.
was a ham operator mode, but normally there's been some. The FCC hasn't made a hard rule about whether or not you can encrypt certain things. You can encode data over amateur radio
Mhm.
if it's a known scheme.
Mhm.
So there's things like that that would let you potentially encrypt it if you're using a known scheme, like say
Morse code.
P25 or X25. That's a known scheme for encoding data.
Because your node will relay traffic that is encrypted, you would not be able to participate in the commercial
Okay.
community mesh. So all the ham operator, I've met with 4 different clubs, and I've explained we only want to play in the same sandbox as the consumers. We don't want to play in the licensed operator space. Maybe someday we'll have a separate ham
I'm thinking more
mesh
for
as
like
well.
emergency communications or RACES or ARIES would want to have a non-public, just an amateur radio operator one because of the amateur radio aspects of those things.
The only advantage they would have, they'd lose encryption, they'd lose that kind of side, but the only advantage they'd have is they could push 10 watts instead of 1 watt. That's the big
Longer
difference.
range for like an actual emergency.
Correct, but if
Depending on the amount of nodes that are available, mesh might actually go farther.
the mesh is probably going to go further because you're not going to have as many nodes to propagate that message for you. And that world record of 200 miles was mountaintop to mountaintop with with a commercial stock, kind of setup. It wasn't anything particularly, over the top.
The Wi-Fi world record is the same thing. It's basically amateur radio power into high gain antennas on mountaintops in less seconds.
But they did that world record without amateur radio power.
Oh, okay.
We'll get DFU to climb some antennas and hang some of these up to make you feel comfortable.
No,
If you want.
I already been
Probably ask
looking.
our buddy.
You already asked them?
No, the cupola on this end of the building has antennas on
Oh.
it for the cell tower.
I mean, honestly, we could actually probably ask the people here if they throw one up. They probably will absolutely do it for us on the roof if you want.
Yeah, so somewhere like
Ethernet.
here would be great.
Ethernet to the node, short link to the antenna. Otherwise,
Yeah.
because otherwise you're wasting a lot of bandwidth on distance.
Yeah, these frequencies and these power levels, we want to make sure the antenna is directly connected. We don't want to run cables. So you want to put the node on the roof, not the antenna on the roof with a cable running down. There's some situations where it can't be avoided. Theoretically, even on consumer grade,
Sorry, say that one more time, please.
yeah, so you want to put the antenna
Hear what you said.
on the node and put the whole node as high up as possible. You don't want to run a coaxial cable like you might for ham radio equipment, because at these frequencies and power levels, there's so much cable loss that you might lose half or more of your signal, even over a short cable length, like 6 feet or something like that. So, yeah. Any other questions?
Have you tried doing is my mic on? Hello?
Yes, I hear you.
Okay, I've been trying to do range tests. Have you messed around with that?
Yeah, so there's a range test function in the Meshtastic firmware. If you've got an ESP32 base node, it can be like the server for the range test, and it'll send sequence 1, sequence 2, sequence 3 based on the frequency of update that you asked for. And then with another node, you can collect that data and see as you're going around town, yep, every 30 seconds I'm getting a ping. And then you don't get a ping. You're like, okay, this is a dead zone. This is an error. Maybe from a little higher up, we've got better coverage. One thing to be aware of, try not to annoy your fellow meshers by doing your range testing on the public channel. They won't see it unless they have range testing turned on. But if they have range testing turned on, then they're going to maybe get your 10,000 messages. And do try and turn it off because you're using a lot of airtime with those messages. Myself personally, I message the Buffalo bot or the Buffalo meshing around bot, and the meshing around one or the mesh monitor. And if you were to say ping as a direct message to it, it will respond with a emote that'll put your hop count. Or if you message the other bot, it'll say what your RSSI and signal noise ratio is. So you get real-time information everywhere that you go. If you can reach that bot, then you're reaching the greater mesh because that bot is dialed into the greater mesh.
Okay, cool. I put one on a kite, and the string was like 650 feet long, but the problem was that was out of range of my Bluetooth on my phone. So
Yeah.
And so the other problem you're running into is antenna orientation, because while those sticks don't look like they're directional, the signal only comes off the side of them, not off the point.
Of what?
There's also lightning, Mr. Franklin.
Well,
So, like-
so I've personally put a node on a kite before and on a drone before, and that can help you get more height, get you out. These are
Drone's a good idea. I
Yeah,
like
these are
that.
relatively light. Tethered drone would be great because the FCC, FAA, regulations are a little different for tethered drones as well. But the one thing I would say is you just need two nodes, right? You want your node to talk to the other node over LoRa, and you could be as far away as you want. If you got line of sight, you could be hundreds of miles away. Theoretically, you could put a LoRa. If we can scratch together $300,000, we can get one up with SpaceX can put one up on on a satellite for us. But if we I see we got a. Is this your hello?
Yes, that
Okay,
was.
so, yeah. If we, but if you can get higher, that's great. You might have to consume that hop to get out. So your one on the ground, that's the one you're Bluetoothing through, and then you let that one up in the sky be your client base. And so your client hits the client base sends it out to the rest of the world. That's the way I would run that experiment next time.
Okay, cool.
Absolutely.
What would be the use case for, I mean, besides, like, if you're out in the field and you can't get a signal, then putting it up on a drone, obviously that makes sense. But beyond that, is there any kind of other
Oh,
solution?
with a drone, I'm almost certain I could reach Toronto. So if I had a drone that was, floating up at the right height, now the 200 to 400 nodes in Toronto are enmeshed with the 200 nodes in Buffalo, and now we're all one happy community. Maybe we'd be talking to Rochester too. Yep.
Because it's line of sight.
Yeah,
The
I
curvature
remember.
of the earth is what you actually run into a problem.
There was a beautiful point in time where someone had a Meshtastic node on the CN Tower, and I was meshed with Toronto.
Wow.
Yeah.
I guess if you want to do that, you could just get a new DJI. Never mind, actually, you can't get a new DJI drone. So
I think they're still for sale. The execution on some of these policies is not aligned with the statements. But, yeah. All right.
Cool.
Very good. Thank you all.
Thank you.
Thank you for having me.
I haven't been paying attention to the news. What's the DJI thing?
Chinese drones are illegal in the United States to
Oh
sell.
yeah, like they're not all Chinese. Like there's any, I can't think of any drones that aren't
An
made in
American
China.
drone, it's actually made of iron.
I don't know when
Powered.
I don't know when it kicks in.
840 pounds.
I mean,
Runs on coal.
Buffalo, the city of Buffalo
Yeah, but it's a
has a commercial IR drone they purchased last year, 2 years ago. I saw the invoice. Somebody posted the invoice online.
How much was it?
$50,000.
Okay.
It's the same guy who bought the hovercraft for Chickamauga.
No idea, but it was definitely a Buffalo City Police Department.
All right. Thanks, man. Already not sleeping well.
crash it next week.
I'll see if I can reach my bot.
Amen.
I don't think I can though, but I'll try.
I wanted to talk
Well,
about
we've been doing that
guest
for-
lecture for one of my classes, two of my classes.
Oh, sure, we talk. All right. If nobody else has any questions, I'm going to go ahead and shut the meeting down. Thank you so much for coming to talk. Thank you everybody for coming to listen, and I will hopefully see you next month. We've got a guest speaker talking about Graphene OS. That should be really exciting. Take care.